friends, welcome to my channel Civil 3D Pro Designer. In this video we are going to discuss about two-peg test. If you are land surveyor, then you must need to know that how to check calibration of auto level and how can you determine error in auto level. So you must need to watch complete video to know about two-peg test, that how can we proceed two-peg test in field to check our error of auto level. If you are new on my YouTube channel, please subscribe Civil 3D Pro Designer. Here you can get many informative videos about land surveying and AutoCAD Civil 3D. You can also access me through my Facebook page Civil 3D Pro Designer. Here you can get many more PDFs and projects, real-time projects about Civil 3D and land surveying. So what is two-peg test and why we use two-peg test? Two-peg test, we will learn also about temporary benchmarks and establishing a TBM. TBM means temporary benchmark. So what is two-peg test? The two-peg test is used to check the condition of the instrument, that it is working properly or not. We have 5 steps to check the instrument condition. Step number 1, set out two-peg 50 meter apart. Step number 2, set instrument midway between two pegs. And step number 3, take a staff reading to peg A, then peg B. In step number 4, we need to move our instrument 3 or 4 meter behind the peg A or peg B. You can select any one, it's not compulsory that point B. Step number 5, take a staff reading again on point B and then point A. Now you will learn in this book. I have these slides, I will put them in description link so you can download and you can also study them by yourself. As we have step number 1, when we will set two peg A and peg B at 50 meter apart, and step number 2. In step number 2, we will set our instrument in the middle of these two pegs. Then we will take reading on peg A, which is for example 0.469 meter, and point B we have 0.37. so we have two readings. For now we need to minus them to get difference, which is true difference. Why it is true difference? Because if our instrument have error, when we set our instrument in the middle of any 2 points, it will take correct reading and it is our true difference. Step number 3, step number 4. Now we need to set our instrument behind the peg B. It should be 3 or 4 meter behind the peg B. You can also set it behind the peg A, it's not matter. Then take again reading on point B and point A, so you can make difference between these 2 points also. Now we have two difference in both setups. How can we measure the error in instrument? Error in instrument will be is equal to true difference minus difference. True difference was the first set of readings and the difference was the second setup reading. When you will put your difference and minus them, you will get error here, which is now 0.091 meter, and it is not acceptable. 0.091 meter is over 50 meter. If you will take these reading on 100 meter, it will something like more, or you can also calculate with this 50 meter error that multiply by 2 you will get for 100 meter. How you can put, or you can say how you can book your readings in leveling book sheet. You need to make this type of Excel sheet: backside, intermediate, foresight, HPC for height of instrument, and which we have not here, reduce level, station, something like this sheet. And for from center, it was our first setup: peg A, peg B, foresight. You can put your readings and true difference will be 0.099, and then from peg B 0.19 you can minus these two readings to get your error 0.091 meter over 50 meter, which is not acceptable, and allowable error is 0.005 meter over 550 meter. So this allowable error also depend on your criteria of design and your standards of design. Now we will see what is temporary benchmark. Temporary benchmarks are survey marks made by ordnance survey, and a temporary benchmark are survey marks set up by surveyor. So you can read these this book by yourself. How can you establish your TBM? It's very simple. Just set up your instrument, and you have, if you have a noun point, you can make backside and plus these two reading to get your height of instrument. Then you can put your stuff on your target TBM and take reading which will be minus from your height of instrument to get you TBM elevation. Like this reduced level we have for OBM, it is our noun elevation. We take backside on our BM, and once we will plus these reduced level into backside, we will get HPC. And now we have foresight on another point. We can minus this foresight from our HPC to get our elevation of lamp post 2. Once we have lamp post 2 reduced level, we can read backside on lamp post, and you will plus these lamp post backside into reduced level to get this HPC. Later you can go back, you can close your procedure for shifting elevation. Again take backside foresight on your OBM, and now you can minus and see here what will elevation. Now we have new elevation 77.560, which was before 77.558. so it is now you can make arithmetic checks for your procedure, which is the sum of back sides and the sum of foresight. You will get 0.002. Then first RL minus last RL, you can see 0.002. These two difference are same, which mean we have fine arithmetic check. But you can see here we have maths okay, but we get error 0.002 in our OBM elevation, which we can also adjust. But if it is our math is okay, we